Welcome back to our channel, our subscribers and viewers. And this is MotoMouth Uganda. We are going to dive into the intricacies of batteries that are used in hybrid cars and electric cars, because this is the major component of these cars. It is almost 80% of that car. So we need to know what it takes to maintain these batteries, to replace them, to charge them, and all other details, as Engineer Ivan Chibuka will be telling us. You're welcome, Engineer Ivan.
Thank you very much, Alan, for the short introduction. This is going to be like a continuation of the previous video where we discussed the powertrains on electric cars. Once again, as is the habit now, I'm going to use to share PowerPoint presentation for this. So the topic is still automotive electric powertrains. But now we are going to look at where these vehicles store their power, or where they draw it from when they're on the road. So when you look at EV battery performance, you realize that the most important battery performance parameters are the state of charge, the level of charge of the battery, that is, the efficiency of the battery, the energy content that can be stored by that battery, the energy density. These are different. Energy content and energy density are different. Energy density is how much energy you can store per unit mass. Energy content is the total content of the total electrical content or capacity of the battery. So the higher the energy density of the battery is, the higher the energy content will be in a given volume of that battery. I hope that one is clear. And then we are also looking at the cycle life of these batteries. How many times can they be charged and discharged before they become useless? And the C rates, that is the rate at which they are charged or discharged. You know, all these bear, they have a strong impact on how long the battery will last, how it performs, its efficiency, and so on, and which battery design the manufacturers opt for. Normally, they are going to opt for the one with the highest energy density. But then again, some chemistries, because the chemistries used in these batteries are different, you may find a chemistry with the best energy density is not very safe. So you may find it is not yet being used in EVs. So there's a number of factors to look at when deciding on a battery to be used on an EV. It goes back to the questions you were asking, how far the Chira guys are with their electric buses and the cars. Maybe these are some of the challenges that they are going over before they launch. Various manufacturers at different stages of knowledge and capability of production of these EVs. So now we are going to talk about the voltage capacity characteristic when charging and discharging. I decided to begin with this because it's quite important. A lot of people who are selling, I've noticed those people who are selling or repairing the battery modules. You know, the battery packs, usually you have a big battery pack that is considered to be the high voltage battery, but it is made up of individual cells. And some of these cells are arranged in modules. You may have 6 cells, like in the Toyota hybrid. You usually have a module that has 6, or in larger battery packs, 8 cells making up a module. So you may have like over 100 cells in that battery pack, but they are packed in 6 modules. In modules that you have one cell, you then have 6 cells making up a module, or 8 cells making up a module, depending on the size of the car they are going to be fitted in. And then these modules will be piled up to make the battery pack. It may be confusing, but I don't know if I've explained it well. You have a cell, usually the cell is about 1 point something, produce about 1 point something volts, 1.2 for cadmium cells. And then they are built into a module, which means they are lined up in series. So you get a module producing a nominal 7.2 volts. And then those modules are again packed together manually to make up a battery pack. You may find a battery pack, say for a Toyota Fielder, with maybe 22 or 21 or 20 modules, depending on what Toyota decided. I know at least for the Aqua, there are 20 modules that make up the battery pack. But each of those modules is made up of 6 cells. So when you look at, all these cells and modules are wired in series. So at the end, the battery pack is going to produce 120, 144, 160 something, even 200 volts is possible in DC. These are little levels of voltage. So don't play around with the electric and hybrid cars. Don't take them to just about any garage. Take them to garages or professionals that you are sure can handle, because they can result in death besides starting fires and becoming dangerous that way. You are playing with the umeme. What is Swahili for a lot of electricity? Umeme mkubwa, my Swahili is broken. Yeah.
I think it would be umeme mingi.
Masanyalaze manji, manene. Yeah, so I need to caution people, because I know sometimes once you share information like this about batteries, somebody is going to want to open for themselves. Please don't. You find in hybrid and electric cars, systems that are high voltage are normally colored in red or orange. Once you open and you find the orange cabling, please stop. You are playing with the fire, literally. So I wanted to caution people who repair or otherwise interact with these batteries that you do not test the health of these batteries by using a multimeter and reading open circuit voltage. That's not enough. For you to know the health of these batteries and to know how much life is left, there is professional equipment that we use to drain the electricity out of these batteries as we are counting the coulombs, or the units of electricity that we are either putting into or draining out of the battery. That is the only best way of knowing the state of health or capacity of a battery. Because when you look, I'm dwelling here, I'm going to spend some time on this slide for good reason. When you look at these graphs here, for example, when you are draining the battery, when the battery is full and you are draining it and you are using it, do you notice the biggest chunk? And this is kind of, it has been squeezed. This graph has been squeezed. In reality, this graph is kind of usually drawn out. It's usually longer in the horizontal direction. So the middle part of this graph is relatively flat. So if you are reading voltage, just reading voltage, between here, I don't know if you can see my cursor, between here and here, where the battery, between when the battery is at about 80% and at about 20, 30% electricity left in the battery, the graph is kind of flat. So the voltage is not changing that much. So simply using a multimeter to get one reading may deceive you, because you may get a reading like at this point here where it is 30% capacity left. You may read it and think you have a lot of power left, only for you to start using the battery and the voltage suddenly falls on this cliff here. So that's why you need professional equipment to test these batteries for true capacity. It's the same thing happens on the energy in curve, with the exception of the lead acid battery, which I discussed in a previous video. The lead acid battery gives you energy it's very happy to give it to you in a lump sum, but when it is charging, it is very, very sluggish. These other battery chemistries are better than the lead acid battery, as in they have similar, they take a similar length of time when discharging at the same C rate when they are charging. So the energy in curve here is similar to the energy out curve, only that it is opposite. It is kind of like a mirror reflection. I know I'm getting a bit technical here, but I needed to stress the importance of testing these batteries and modules properly with the right equipment, with the right people, because it's very, very easy to lose money by replacing a bad module or battery with another bad module, which just before you install it looks good by just measuring voltages, but in reality is low in capacity, and you are just going to come out worse than you went in. So I needed to stress it by showing you this graph of charging and discharging. Yeah, and then the total capacity decreases with the number of charging and discharging cycles. When the battery is very new, most of the time you get 100% of the stated rate capacity if the battery manufacturer is reputable. Some battery manufacturers are fake. They would say battery is, they sell you a battery and claim it is 80 amp hour capacity when it actually has 20. I've come across this in when we are testing in the workshop. But assuming you get a battery from a reputable manufacturer that gives you 100%, sometimes they even give you more than 100% at the beginning when they are brand new. They give you more than 100% of the stated capacity. When you charge and discharge it, the chemistry going back and forth, charging, discharging, the battery gets old. That is the nature. There is little we can do about it. Once it gets to about 80% capacity left, rated capacity left, usually you should change. If it's a module, you should change that module. And that is usually the point at which the vehicle's computers start to complain and shut down the vehicle. Or at least if it is a hybrid vehicle, it will shut down the electrical side of powering the vehicle. If it is an electric vehicle, it may even refuse to move. It may shut down completely. So it's a good habit if you have, just like you have general service for a vehicle, if you buy the vehicle brand new, after 4 or 5 years, most of these manufacturers give 5-year warranties, some give 8. I think Toyota have gone as far as giving 12-year warranties on these batteries. So once you go beyond the warranty period, the stated warranty period of the battery, it's a good idea to bring the battery for testing so we know exactly how much life is left in the battery, and then you can prepare in good time before the vehicle decides to shut down. You can prepare in good time to replace the battery. And when you test the modules, you can even tell which modules are due to be changed first, which modules are deteriorating first. For cadmium batteries, which are, I think, common in first, second, and third generation Toyota Priuses, for example, we can even take the batteries through a regeneration cycle where you can recover some of the lost capacity. It's all a bit complex. It's those cells, how they charge and discharge over time. Some of them start discharging faster, or they reach the voltage cutoff for charging and discharging before the others, and then the vehicle will simply stop. Once any one cell or module reaches the cutoff voltage, either for charging or discharging, the vehicle will shut down charging or discharging the entire battery pack. But when we are testing, we are able to see which cells or modules are doing that, and then we discharge them or charge them a little bit longer so that they equalize with the other modules or cells. And then at the end of it all, you have a battery that regains some capacity. So if you brought it when it is at 79 and we go through that cycle, you may recover and have it back at maybe 87 or 86% capacity. And then the C rate is the rate at which you charge or discharge the battery. This relates to the current that you are drawing or pushing into the battery when you are charging it. Drawing from is when you are discharging it. Pushing into is when you are charging it. So the slower or the lower the C rate, the lower the charging or discharging current, the more capacity you are able to store in a battery or get out of a battery. I don't know how to explain it except just to tell you that is just how it is. That's how nature is. That's how the chemistry is. You see on the in the graphs on the left, you can see that the higher the charging rate, say a charging rate of 220C. 20C means if you have the C rate is, I'll give you an example. Maybe you understand it better. If you have a battery that the manufacturer is claiming is 100 amp hour battery, it has 100 AH written on it, and you discharge it using a current of 100 amps, it should last at least an hour. It should give you that current for at least an hour. That is why they are calling it amp hour, AH. So if you discharge it at half that rate, at 50 amps, it should last 2 hours, and so on. In reality, that is in theory. In reality, that it doesn't happen like that. Why? Because with a higher charging or discharging current, there is energy lost in heat. The chemical reaction going on inside the battery to give you that high current ends up producing heat, and heat increases the internal resistance of the battery. So you lose two ways. You lose energy via heat, does not arrive at the battery terminals to be used to be consumed by the vehicle, if it's the vehicle that is discharging it, and also the temperature is increasing the internal resistance of the battery. So you are losing energy. That's why high relatively high C charging and discharging rates are not good. And you can see it in the graph. That's what these graphs that I've shown you here are talking about in a nutshell. That's what this is about. And the effect of C rate on battery efficiency, again, like I said, the higher the C rate, whether you are charging or discharging, the lower the efficiency of the battery, because some of the energy, some of the electrical energy being pushed into the battery or being extracted out of the battery is lost in heat. That's what this graph is all about in a nutshell. And here is a sample of charging and discharging cycles of a battery that we tested a few days ago in our workshop, just for purposes of teaching and sharing. The first phase is charging the battery. This battery has a nominal voltage of 6 volts. So we used about 6.9 volts to charge it, constant voltage charging, that is. And then once you see the blue line is voltage, the red line is current. So if you look on the left side of the image, you see the voltage is constant, about 6.9 volts, constant charging voltage, but the current is falling because the battery, as it charges up, as it fills up, it gets the internal resistance increases. Internal resistance increasing means the current falls. So once the battery was fully charged, the current reached about 0.15 amps. This was automated. I programmed the whole sequence, and then I left the equipment, the machine to take the battery through the cycle. Once the battery was fully charged, it was now discharged using 10 watts. And you see that the voltage decreased while the current increased. Naturally, when you are discharging a battery, the voltage is going to decrease. This was a lead acid battery, so it loses voltage quite markedly. It's quite visible, unlike lithium ion graph that I showed you earlier. But the equipment automatically increases the current that it is drawing from the battery to maintain the 10 watt discharge rate. So at some point, once the the voltage has fallen below a set limit, it stops, because this is what I had programmed. I told it once it reaches about 5.4 volts, stop discharging the battery and charge it up again. So we go into the second charging cycle. The voltage goes back up and the current also initially climbs because the battery is thirsty for current, and then keeps falling until it is fully charged again. And then this time we discharge it with 5 watts, which is like half the 10 watt discharge that we did earlier. And then you can see that this time the current rose a little bit slower, at a slower rate, and also the voltage fell at a slower rate because the discharge rate was less. It was about half the first cycle. And then we went into the third charging cycle. Battery voltage went up. This is the voltage from the equipment that is charging the battery. It maintained the voltage. That's why you see a straight line here. But again, once again, the current starts off high. The charging current starts off high, but as the battery is filling up, it falls. And then again, we went into a 2 watt discharge cycle. And that is how the discharge cycle ended. It went on and on and on and on. That's why I had to make a second image. But you see now it went on and on again. But I had 3 discharge cycles, but with each of this discharge cycle, I got more power during the last, more capacity extracted out of the battery during the last discharge cycle, which was 2 watts, than I got out of the same battery charged to the same level during the second discharge cycle. But I got more power or capacity out of that same battery again. I got more power out of it during the second discharge cycle than I got out of the first discharge cycle, which was faster, which was a bigger load. I may be talking a lot of electricity here now, but if you need to follow this, you can rewind the video and try to follow the graph and try to follow what I'm saying. But in short, the harder you discharge or charge a battery, the less capacity you are able to push into that battery or get out of it. That's just the chemistry. That's how batteries operate. So I've given you a snapshot of what goes on inside batteries. Regarding chargers, wall chargers for, or commercial chargers for electric vehicles, some of you may have come across a few of them. In Kampala, we have them available. I've seen them at Arena. You go to MotoCare because they are selling electric vehicles. They have chargers there. For most vehicle owners, they have a small wall charger which you plug into the socket in your house or garage. But for fast charging, you need to connect to a commercial charger like the one in the graphics you are seeing. So you notice that these sockets have several holes. It's not just a positive and negative charging of the battery. You have multiple holes because they are using AC, and usually they are 3-phase, so you are going to need at least 3 large wires. 3 of the large wires are going to be phase, and then you have communication wires in the cable. When you connect your vehicle up to the charger, it talks to the charger and they agree. The vehicle informs the charger how hungry it is, how much, what voltage it is at, how low the voltage on the system is. So the charger knows how much current to begin charging with, because normally when the battery is low, the charging current is high, like I showed you in the graphs. That's why I included those graphs in the presentation. The charging current is going to be high, but it will reduce. So it will reduce as the charging process goes on, as the battery fills up. And the vehicle needs to inform the charger accordingly, and then the charger also needs to talk to the, basically they work out. All you have to do is connect them up, set up the charging process, whether you have to pay for it or whether it is free, whatever. And then these two, the charger and the vehicle, will talk and the charging will be completed. Yeah, like shared before, at Process Control and Automation Engineers, we comprehensively test these EV, HEV, and PHEV batteries and modules. So if you need more detail than I have provided here, you can inbox me and we talk about EV and HPEV, PHEV batteries to length. For now, allow me to stop here and share with you. Rather, if you have any, Alan, if you have any questions or comments to share, we can go ahead.
Thank you very much for the detailed explanations on how these batteries work, and how their life cycles, run. My comment would be on the commercial charging stations, because if someone was to acquire or a hybrid, they would want to know an electric vehicle, that is, they would want to know where They can roam in case they run out of juice, as the Americans call it. And also they would want to know how long it takes to charge if they try to do it at home.
Okay.
Because, you know, our power is not reliable and someone needs to plan whether to do it the whole night or 2 days. Yes.
Yeah, so they sound like two questions, but they come back to the same thing, reliability or availability of charging facilities. Like I mentioned here earlier, every owner will get a home charger with their vehicle. So once you are home or anywhere where you have access to mains power, you will be able to charge the vehicle. The home charger, though, is slow. It is charging at a small C rate, at a low C rate. We've just discussed C rates. For purposes of safety, it's mostly for purposes of safety, and also for purposes of ensuring that the battery lasts a long time. Why? When you charge at a high rate, like what the charging station, the commercial charging station that you've come across is capable of, you are reducing the life of the battery. A battery that would have lasted you 15 years, if you keep charging it at only fast rates, you may end up getting like 4 years out of it. If all you're doing is strictly charging it at high rates. That is why most manufacturers have built-in limits to how many times you can fast charge your vehicle. When you overdo it, it will stop accepting fast charges. Why? Because in the long run, you are going to run back to them and complain that the battery did what? So you are going to get a mix of, the best thing to do is to charge the battery slowly, because that means it will not heat up and it will store a lot of charge compared to when you charge it fast. Fast charging is a battery killer. Fast discharging is also a battery killer. So they are trying to allow for some kind of compromise. You get a few fast charges when you are squeezed for time, and then most of the charging you are allowed to do it at home using the home charger. So they are going to limit you in that for very good reason. So those fast chargers should not be something you are using every day. The fast chargers are also capable of slow charging. So when you take it for charging, most times you are advised to use slow charging. But slow charging means the vehicle is going to spend a long time there. Ask yourself, do you live your life in that vehicle? No, you don't. You may find out of 24 hours, on a regular day, you spend only 1 hour in that vehicle. So that brings us back to the question, do you actually need to be fast charging all the time, or you need to plan your charging better? So even you can live, if you plan your trips well, you can very, very comfortably live with slow charging. You may not even need to use those high current charging sessions if you plan your trips well. But let's say once in a while you've gone to Masaka and you need to get back on the same day, and you don't have 6 or 7 hours to spend charging the battery while you are in Masaka. So then you can use the fast charging option if you have access to it. Fast charging is not the solution to your problems because of the technology, because of the chemistry. I don't know if I have answered your question, but now again, you asked how readily available are these fast charging stations? There are few in Kampala. I don't know if there are any in Jinja, Masaka, Mbarara, whatever. Why? Why is this the scenario? We have a chicken egg situation here. No company is going to invest in commercial chargers when there are so few vehicles. And again, it is hard to encourage people to buy more EVs when there are so few chargers available. So we have a chicken egg situation here. That is why the guys of the border borders are on a winner, because for them, they'll tell you around Kampala we have a charging station within every 5 kilometers. So you are assured. Now, if they were to launch in Masaka town, they would also put those charging stations. You get? So they're on a winner, but the guys who are selling cars may not do that, because in any case, you don't have vehicle charging, battery swapping stations for vehicles. I know some Chinese companies are doing this in developed countries. I don't know how successful it is. It's likely to be successful, but remember that these people also have to invest money. So when you don't see many charging stations, you need to understand why. I'm not going to answer you that there are many or there are few, but I just want you to understand there are factors that determine why you may not readily get access to fast charging station. But also, even if you had access to them, it doesn't mean that they are your solution all the time. You spend only 1 hour in the vehicle a day, you have 23 hours to charge it. So plan your trips and how most of us have access to mains power or meme power or solar. We could plan along that. We have less than a minute left. I don't know if I've answered your question or if you have more questions than the comments.
You have answered it, especially explaining the need for people to charge their batteries at a slower rate than going for the fast charging. I think that is very important for the life of the battery and the general health of the car.
Yes. Yeah. So thank you very much for hosting me. And thank you very much, our viewers, for taking your time to view this video. We shall come back as MotoMouth to discuss other aspects of our vehicles. I know we still have a lot to discuss about cars. Yeah. Thank you very much, and goodbye to you, Alan.
Thank you.